Greetings mathematicians, welcome to this third presentation on analytical geometry focusing on circles. Today we focus on tangents to circles. So, this particular part of analytical geometry really provides a bit of an intersection between Euclidean geometry and analytical geometry. So these are some things you need to know before we proceed. 1. A tangent is a line that no matter how far it is extended, touches the circle at only one point. 2. If you recall from Euclidean geometry that a tangent to a circle will be perpendicular to the radius of that circle at the point of intersection between the tangent and the circle. 3. Recall also from Euclidean geometry that tangents from the same point to the same circle will be equal in length. 4. A common tangent is a single line that is a tangent to more than one circle. Wow, that's poor spelling. Anyway, it should say more than one circle. Moving steadily along. Here's an example. Example number 1. A circle is described by the following equation. There it is. We need to determine the equation of the tangent to that circle that passes through the point 6 and 2. Let's see what we have here. It may help to sketch the scenario. Here is a sketch. Look at that. Aren't my artistic abilities fantastic? There's the circle with its center. Of course, I get the coordinates for that center from the equation there. There is the tangent, broadly speaking. That is the point at which the tangent makes contact with the circle, somewhere over here, 6 and 2. And that there is the radius that goes from the center to the point of contact between the circle and the tangent. Now, this whole question revolves around the fact that a radius and a tangent are going to be at right angles to each other. So if we can work out the gradient of the radius, then we can use analytical geometry to work out the gradient of the tangent, and from there we can work out the equation to the tangent. So let's start with the gradient of the radius. There's the gradient formula. We fill in the coordinates of the center and of this point of contact here, that's at the end of the radius, and we get a gradient of 5. Now, we know that if two lines are perpendicular, then the product of their gradients will be -1. So that means the gradient of the tangent must be -1/5, because -1/5 times +5 gives us -1. There we go. So now we know what the gradient of the tangent is, and we know that the tangent is a straight line, so its equation is going to be in this format, y equals mx plus c. We have just worked out what the m is. It's -1/5. There it is. So all we need to do to finish up is to work out what c is. The way we do that is by substituting in the coordinates of this point here, because this point is on the tangent. Substitute those coordinates in place of the x and y here, and then we can solve for c. So c is 3 1/5. So that means that the final equation to the tangent is that. Red box of glory. Okay, let's move on to our next example. Oh dear, that looks like a lot. But don't worry, it's not too bad. Let's have a read through. In the diagram alongside, the equation of the circle with the center F, so this is the circle with the center F, is that S is a point on that circle. Another circle with center G, that's this one, touches the circle externally, touches circle F externally at H. So this circle and that circle touch each other externally at H, such that FH, which is that radius there, to HG, which is the radius of the big circle, is 1:2. So the ratio of this radius to that radius is 1:2. The point J lies externally in the first quadrant here, such that JH is a common tangent. So JH, this line, is a tangent to this circle and to that circle. And JK is a tangent to the circle, the big circle, here. It's a tangent at K. So first we need to determine the length of FS. Well, that's not going to be too difficult. We are just going to use the distance formula. But before we do that, it might be helpful to write down the coordinates of f from our equation. There we go. I remember this is our x coordinate, that is our y coordinate. All we do is change the signs. So -3 becomes +3, -1 becomes +1. Those are the coordinates of f. Now we can use our distance formula. There it is, to work out the length of fs. Plug in all of our coordinates from f and from s, work it all out, and fs is 5. So next up, question B, we have to calculate the length of hg. Oh, there's the little red box to say that that is an official answer. Right, question B. We need to work out the length of hg. Well, we've just worked out that fs is 5. So that means fh is also 5 because they are both radii of the same circle. In the question, it says the ratio of this to that is 1:2. So it must mean that hg is 10. Ha ha! Right, question C. I've forgotten what question C asked. Let's go back. Question C, determine the length of fj. That's from here to here. Determine the length of fj if we are told that jk is 20. So, we are trying to work out the length of fj. There it is. We are told that jk is 20. Well, first, we know that jk and jh are going to be the same length because they are tangents from the same point. So if jk is 20, that means jh is 20. We have previously also established that fh is 5. Now you will remember that a tangent and a radius, jh is a tangent, fh is a radius, are perpendicular to each other. So that means that fhj, that triangle there, is a right angle triangle, so we can use Pythagoras to work out the length of fj. There we go. So this is the length of fh, which we worked out previously. That is the length of hj, which we were told in the question is 20. Work all of that out, and fj is 5√17, aka 20,62. And wait for it. There it is. Now question D, which I believe from my memory was to determine the equation for the circle with a center G. Let's have a little look-see. So we already know what the radius of this circle is. Whoopsie, it's 10. We figured that out for question A, I believe it was. That is, no, question B. That this is 10 units long, so we know what the radius is. We are told that the equation of jk, that's this one, is x equals 22. That is the equation for this line. Now that is a very specific kind of equation. That is the equation of a vertical line. So we know that jk is a vertical line going through 22. So all of the x-coordinates on this line are 22. So that means that gk, if this is a vertical line, and it's a tangent to the circle at k, and gk is a radius to that circle, gk and jk will be perpendicular. And if this is a vertical line, it means gk will be a horizontal line. We already know that gk must be 10 units long because the radius of the circle is 10. Gh was 10, so that means gk is 10. Now, if the x-coordinate here at k is 22, because all of the x-coordinates on this vertical line jk, all of the x-coordinates there are 22, and gk is a horizontal line of length 10, we can count back to work out what the x-coordinate is here. It must be 10 less than 22. So the x-coordinate of g must be 12 by counting on. So we know what this x-coordinate is here. Now we just need to work out what that y-coordinate is. Oh wait, there's a little blue box. Now we need to determine the y-coordinate of g. So we know that the distance from F to G is 15 because that's 5 units and that's 10 units. So from F to G is 15 units. We can use that information plus the distance formula to work out our final missing coordinate, which is n here. Because I've got both of the coordinates for F, I know the length of FG, and I have one of the coordinates for G. So that means I've only got one piece of information that I do not know yet. So we're going to use the distance formula. There it is. I fill in everything I know. I know what both x coordinates are. That one's 12, that one's 3. I don't know what the y coordinate at G is, but I know what the y coordinate at F is. There it is. Fill that all into my distance formula. And now I have an equation. It's a quadratic equation, so I get everything onto one side and a 0 on the other. Factorize, get 2 answers. Now I have got 2 answers here. I've got to select which one is it. Bear in mind that n is a y coordinate in the 4th quadrant. What do we know about all the y coordinates in this quadrant? They're all going to be negative. So our answer cannot be positive 13 because this y coordinate cannot possibly be positive 13. So it must be negative 11. There we go. Oh, another blue box. How exciting. So that means the coordinates of G are 12 and negative 11. Ha! Yet another blue box. Wow, what a lot of blue boxes that is. Lockdown's getting to me. Blue boxes are exciting. So, the equation for the circle with a center G is going to be given by this. I filled in the coordinates of the center there, and we already knew that the radius was 10, so 10 squared is 100. And there, ladies and gentlemen, is the final answer to question D. Okay, bye-bye.